The cat drank the milk because it was thirsty. Every AI that reads this sentence has to decide in a microsecond, who is it? The cat or the milk? Watch it decide. It picked the cat, and that entire decision came down to any number, the dot product. By the end of this video, you will compute it yourself and watch it swing from agreement to nothing to opposition. Here are two vectors, A at 3, 1, B at 2, 2. The dot product has two recipes and they always give the same answer. Recipe 1, multiply matching parts and add. 3 times 2 is 6. 1 times 2 is 2. 6 plus 2, 8. Recipe 2, multiply the two lengths by the cosine of the angle between them. Same vectors, same answer. 8. One is arithmetic, one is geometry. The dot product is where they meet. Two people pull a cart. Pulling the same way, their effort adds. At right angles, one contributes nothing to the other's direction. The dot product is exactly that. How much one pull helps the other. Watch only the sign. Pointing the same way, positive. These two vectors agree. Rotate to 90 degrees and it lands on exactly 0. Not small, 0. The two directions have nothing to say to each other. Keep going and it turns negative. Now they actively fight, like a tug of war. Positive agrees, 0 ignores, negative opposes. One number, the whole relationship. And when it is exactly 0, something special happens. AI builds on it. That exact 0 earns a name, orthogonal. Perpendicular directions that share no information at all measure along one and the other cannot interfere. Make them length 1 and you have an orthonormal basis, the cleanest possible measuring frame. Hold on to this. When we meet the SVD in episode 1.9, these perfect frames are exactly what it hands us. Now drop a light from above. The purple arrow is as our shadow on B. The part of it that points along B. That shadow is called the projection. Rotate A and watch the shadow breathe. Long when they agree, gone at 90 degrees. And its length is set by the dot product. That is the formula, dot product over length squared times B. Hold a stick over the ground at noon. Its shadow is the part of the stick that lies along the ground. Projection is that shadow, the piece of one vector that points along another. One catch, a longer vector gets a bigger dot product just by being long. A long document is not automatically more similar than a short one. These two point the same way, so divide the lengths back out. What is left is pure direction, cosine similarity. These two score a perfect 1.0, identical meaning, different size. This is the number behind every vector database and semantic search. And here is why this episode matters. A neuron takes its inputs, multiplies each by a weight and adds. Multiply matching parts. Add. You have seen that recipe before. It is a dot product. The weights vector dotted with the input vector 0.78. Every neuron, in every layer, in every network you have ever used, is asking one question. How much does this input agree with my weights? Now the payoff. This exact number is how a transformer reads a sentence. Now the payoff. A transformer reads, the cat drank the milk because it was thirsty. Who is it? The cat or the milk? The model has to decide with dot products. The word it asks a question, a query vector. Every other word offers a key vector. Toy numbers, real mechanism. Score each word by q.k. Cat 0.72 plus 0.02 plus 0.56, 1.30. Drank 0.51. Milk only 0.31. Thirsty 0.86. Cat wins. So attention flows from its back to cat. The model just resolved the pronoun with the same number you watched swing between two arrows 9 minutes ago. Attention is not magic. It is a dot product per verb. 5 lines gets you a working similarity search. A cosine function, a dictionary of vectors, score them all against a query, take the winner. The full notebook is in the description. The map so far. Vectors carry meaning, matrices bend space, composition stacks them, the determinant measures them. And today the dot product scores agreement. You are here. And what it buys you. Attention scores are dot products. Every neuron is a dot product. Semantic search is a normalized dot product. One tiny operation running trillions of times a second. Everywhere in AI, next stop on the map, every trained model is secretly solving one equation. Ax equals b. Where lines cross, models learn. Next, the one equation every trained model is secretly solving, Ax equals b, and the crossing point at I is the answer. Thanks for watching and keep exploring. Next time, linear systems and elimination. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.